Alessandro. I'm Alessandro Rossi. I'm based in Italy, and I'm a specialist solution architect for Red Hat Enterprise Linux at Red Hat. And here with me is Luca, Ferrari.
Hi, guys. Hi, everybody. Yeah, you can guess my email from the icons. And I've been at Red Hat for, we were speaking before, almost 10 years now. So a little bit scary. And yeah, as you can tell from the image, I'm also deeply involved with the community. I lead some meetups in Barcelona, where I live, and you can find me on those social networks.
Thank you, Luca. And yeah, let's start to see what's on the menu today. So we are going to just make a quick recap of what we announced last year, what we discussed last year. But this time we want to also add, well, after we set the scene last year, how things have changed during time. Where are we today? So we are going to just check some of the latest news, developments, and everything that is going on the bootc, in the bootc world. And then we are going to just check how adoption moved during this year. So what if there are companies that are using, what are the development in the community? And we prepared for you today a couple of demos. They will not be live because they take a bit of time, let's say. They will be recorded, but we will show two very crucial use cases. One is the integration of bootc containers within CI/CD pipelines, and the other one is a demo about managing fleets of devices with flight control. So let's start with a very quick recap. So we talked about bootable containers. So some of the good things are, of course, immutability. So we can start using something and spinning up something up from a container, exactly like you do for applications, but also for the OS part. And again, you can still run bootable containers on their own if you need to run some tests or if you need to just run some of the applications that you want to test. Or you can just deploy the bootable containers on a real system. So it's a virtualized physical cloud environment. It can be potentially everything. And again, they are containers. So you can just integrate the build phase in the same process that you are using for the applications. So nothing changed on the tooling, let's say. And again, since it's an immutable thing, it's a container image, and it will be converted in any format, you can just standardize on any platform, potentially. So whether it's a physical server or a cloud environment or a virtualized machine. Just a very quick recap on the steps. So we've just said that everything starts with a container file. And of course, we are going to build this container exactly like we do with all the containers that we have. And then we are going to push our fantastic container image within a container registry. So the difference here is that the process doesn't stop there. So you start with a container image, and then you are going to just convert this image to something that can be consumable. Think of an ISO, think of a VMDK, think of an Azure image, or a QCOW image. And of course, you can start and just deploy the image. And what happens when you want to update your system? Maybe the application, the configuration that you have, or the operating system itself. You want to make an upgrade. Think of CentOS 9 to CentOS 10 or something like this. You just start with the container file. You go and change your container file to adapt it to your changes, and then you are just rebuilding the container, pushing it to the container registry, and we will see in the building blocks, there will be something that is going to take care of updating the image, so fetching the differences between the two images, and just apply the difference. And again, of course, this can be done anywhere. So it's not something that it just applies to specific environments. What are the building blocks? One of the first building blocks is the bootc image builder. So how do you convert a container image to something consumable? bootc image builder is the component that is dedicated to do this. So it will just take care of converting the container image to those formats that you need. So if you need a physical server, you are probably going to create an ISO. If you want a QCOW image, you are going to just create a QCOW image. And again, this is also supported within, and we will talk about this with Luca. It is also integrated into Podman Desktop. And the other building block is, of course, bootc. That is the core component for managing the installation, the update, and potentially any maintenance operation within the system, the final system. So you can, of course, upgrade, fetching the different layers. And, of course, you can also switch to a completely different container image, because again, this is something that will be managed by bootc directly. And again, I'm just switching up to Luca to talk about Podman Desktop and of course, the latest news that we have.
Yeah, so, well, we will see more of Podman Desktop in the last demo. We've been hearing a lot about Podman Desktop at this conference as well. You can do most of the action needed to build, deploy, and even create a virtual machine now from Podman Desktop. I would honestly say even using Fedora all the time, we seems to be showing actually more love to Mac and Windows than to Linux nowadays in Podman Desktop, because it's supposed that somebody who's on Linux can use command line. And by the way, just to touch on this, you can even now deploy a full image with a lightweight Kubernetes instance with Microshift directly from Podman Desktop in an easy way. And I suggest you explore the rest of the extensions that are available there, because they are really useful. So now for some of the latest news on bootc project. But before this, I would like to thank Colin in the audience, who helped us a lot with these slides. And so let's start with some of the stuff that's already available. When I see available, I mean upstream. So don't assume this is necessarily for RHEL, but most likely for CentOS or Fedora bootc. So the first thing is logically bound image. So sometimes you want to have an application, a containerized application starting right at the beginning and included in every single image you build, no matter the update that you are doing to the OS. This might be because you want to have some basic functionality like logging, monitoring, or other type of agent inside the operating system, and that's what logically bound images is for. So practically speaking, this is an image or container file that's included at the building time. And as part of the first or all the builds, it will pull the image and it will be embedded during the build. So then you have Progress API. So one historical problem, I would say, if you started using this type of approach for operating system, even with RPM OS3, was that you launched this job and you didn't know where it was, how it was going. You had to look into the logs of whichever agent was building the operating system. And now there's Progress API, which allows you to know at what stage you are, what's the percentage, how the update is going, in which phase you are. So this can be also parsed into a JSON object. Then there is a lot of use cases. Actually, I speak with a lot of customers that have their own definition of minimal image. So some of them might include or might not include some packages, depending on the vertical or depending on the use case. So we started to providing from scratch construct. So this means that you can build your own minimal image based on your own definition of what's minimal, and also to fix a specific version of specific package at build time. This still starts from a common base image, which means you don't lose all the updates and security patches that we will provide as part of the base image. Then there is install at runtime. So if you're a developer and you're using some of this immutable operating system, you still might want to test out stuff. You still might want to install stuff. Maybe it's the old habit of having RPM OS. And with bootc USR overlay and DNF install transient, you will be able to do that. So you can open the file system for changes, you install the package, and you relock it. So that's super useful without having to rebuild a complete image. And then we move to stuff that's in progress. So there are several use cases. Again, I come from edge customer, edge computing world, where uptime and availability is super important. You might want to apply patches and new features without having to reboot full machine if you think about some production line. And this is what soft reboot is all about, basically. Then we have alternative architecture and alternative version. So at the moment, if I'm not mistaken, bootc is available for Fedora, CentOS, and RHEL. But why we are limiting just to this type of architecture or to this type of, let's just say, enterprise systems? So I personally use in my home lab also Fedora IoT, which is super useful for a lot of IoT devices, IoT gateway. Why don't we start working on bootc immutable version for Fedora IoT? That's what we're doing as well. And at the same time, we're exploring alternative architecture like RISC-V. Factory reset. So this is something that definitely, again, resonates a lot with edge scenarios, but not necessarily only that. So sometimes you have been experimenting with your operating system, your immutable operating system, and you basically built up a set of configuration that maybe made the system not completely working or not in a state that you want to keep, and you want to just roll back to the golden state that you had when you received the device or the image. So you can do that with factory reset. You can see that in the end, this factory reset is just, again, another rollout and update. So you also will be able to roll back to the previous state. Then configuration management. Why do we have to be limited to some static configuration during build time? So why don't we have a dynamic configuration, and why don't we can't we add a secret at build time that can be, for example, decrypted by the TPM on the device? So all of this is being worked in the dynamic configuration management. This is an example of what the future command line program could be like. And then I conclude with some best practice. So you don't have to read through all of this. One important one, try to, when you're building your own golden image or reference image, try to avoid DNF update at all costs, because it's not always, it's not predictable through different building what it will lead to in terms of images, and also the kernel might be affected. Also, we can now, it was something that wasn't possible before, but at build time, you can also select the kernel version. This is super important, for example, if you're building a real-time kernel image. But as always, use it carefully. And also be aware that some container metadata that you might be used to using for building application containers might not necessarily make any sense in bootc building. So you might lose some of that, or it might make no sense to bootc. And we conclude with something that's, let's just say, a related project, so flight control. As all of this, you can find it on GitHub as flightctl. So with flight control, you have an easy way to manage a whole fleet of devices or installation of bootc images. You can do this in a declarative way using GitHub principles. So you can define the configuration in templates that are associated either to single devices or to fleets. And you can, of course, save these templates in GitHub. And all of this while accessing the devices without any VPN or other type of, let's just say, complex mechanism. So there's a mutual TLS tunnel that's installed, that's created at onboarding time with the device. So this is a little bit what the architecture looks like, and we'll see the GUI in the last demo. I'll pass it on to...
Thank you, Luca. So we've seen that in the last year, a lot of is still coming, and a lot was working on. So we worked on a lot of things now in the bootc world. Now we are going to focus a bit more on how did the adoption go. So what happens is, first of all, we start with the use case. So as Luca was mentioning before, talking with customers during this year has led us to some of the biggest use cases that we can see bootc adapting to. So, of course, AI and ML workflows and devices, for instance. So if you have some model serving software that you need to provide at the edge, or if you have some training components that you want to deploy. And of course, when it comes to, especially this is very interesting for partners and independent software vendors, because bootc is a very good candidate for the relationship directly with the application. So also what Luca was mentioning before with the logically bound images. This is something that having a correspondence, one-to-one correspondence with the application and the host, think of an appliance, it could be a very great use case for this kind of technology. And again, edge appliances, any potential, so sensors or devices that needs to collect data, or think of any other proximity device, like a point of sale or an ATM or anything, a kiosk. You can just print maybe tickets or be a vending machine or something like this. And again, of course, you can still use bootc containers as standalone containers, because maybe you just need to have something running on a machine that is like, or in a machine or in an orchestrator, and you can still use the bootable containers there. So what happened a bit in the world is that we are also trying to move, also the Fedora CoreOS started to be based on bootc, so derived from bootc, and we are still using, of course, managing OCI container image within CoreOS. Of course, it's still different because CoreOS is still based on ignition files and everything, but again, we started deriving from bootc. And again, also Silverblue and the Atomic Desktop project is very heavily relying on the bootc technology. And something that is continuing to rise is Universal Blue. By a quick show of hands, any of you that is actually using or used Universal Blue distributions? Cool. So basically, Universal Blue is basically a set of different, let's say, flavors of bootc containers dedicated to specific aspects. So there is a bootc container for gaming dedicated to gaming. So you can also deploy it on your devices potentially. There are for calculus, there are for AI. So basically, and the rise of first of all, the contributions, and then the adoption of this distribution is rising through the year. And again, we are also shipping bootc containers as image mode, as it's called in Red Hat Enterprise Linux. And of course, it is going GA during Summit. So basically now it's a recognized technology within RHEL, supported within RHEL. And also we have Red Hat Enterprise Linux AI that is entirely based on image mode. So we have a dedicated product that is based on this technology. And now we can jump into the first demo. So we wanted to make something different. So not a lot of command line today, but something that is integration with other tools. So we are going to start with the integration within CI/CD environments. So for this demo, we are adding a couple of building pieces here, because the flow is, of course, the same, but we are adding a Git server and a CI/CD pipeline. We are going to just check what are the components. So the building blocks is Tekton. So if you're not familiar with Tekton, Tekton is a framework, let's say, to create pipelines as code that is tightly integrated within Kubernetes. So it's basically a dedicated way to run pipelines, cloud-native pipelines, let's say. And we are going to use KubeVirt. KubeVirt is basically how you deploy VMs within an orchestrator, a Kubernetes orchestrator. So VMs as containers, let's say. And of course, there are some points that are very good, and they match very good with bootc, because KubeVirt allows using container images to embed the disks for the machines. So this is exactly what we are going to run during our demo. But let's see that in a bit of more detail. So we have a Git repository where we are going to create some webhooks. And of course, when we are going to add a modification or create a release, we are going to trigger something. That is exactly the CI/CD pipeline on Tekton. The CI/CD pipeline will take care of course, building the first container image, signing the image, of course, pushing the image to the container registry, and then converting the image to the specific format, in this case is QCOW2, for the KubeVirt VM. And again, we are then going to, of course, create the template for the VM, and we are going to actually containerize the QCOW image to make it usable for KubeVirt. And again, we are going to use, of course, a container registry to just store all the information. So let's see that in action. So we are going to start with Tekton. So if you're not familiar with, this is the dashboard for Tekton. It will contain all the components that you have in your installation. And we have some pipelines. So we are combining multiple pipelines together to just create the end-to-end flow. And this is the KubeVirt manager. So you can see here the dashboard. I don't have any virtual machine. I don't have any container image. So we are starting from scratch. So we don't have anything in place. The only thing that we have, of course, is our fantastic application. So we have a kiosk VM, a kiosk machine defined here. So in the container file, we are installing GNOME for the graphical part. We are going to set the graphical interface as the default, and we are creating some auto starts for Firefox in kiosk mode that is serving our application that we logically bound directly within the container. So we have a point of sale application embedded in the container, and we are just going to see how easy it is. We just create a release, and in terms of minutes, we have our VM running. The only thing is that we need to specify that we are going to create a release with a suffix, a QCOW suffix, because this will trigger the right pipeline to just create also the QCOW image. And of course, the same pipeline can be used to update then the image. So as you can see, when I created the release, a tag was created, and this tag triggered my pipeline. So it starts with cloning all the information from the repository, and it starts the actual build of the image. So the build of the image is just a container build. So Podman build, and then it is just going to bring everything within the image. And it takes, of course, a bit of time. So what we did for the demo, that's the reason why it is recorded. So we had to cut and paste a bit, all the pieces. But again, after we are, when we reach the push phase, as you can see, we have two tags. One is the app tag, and one is the latest tag. And both of them, of course, are signed. So we also use cosign to just sign the image there. We are going then to convert. So this is the actual conversion phase. Now it is running the bootc image builder part, where we are converting the container image to the QCOW image to make it available then for further analysis. And now it is just creating the container disk. So it is embedding the QCOW2 image within a container image, and it just triggered the VM template. So now KubeVirt is just fetching the container image with the data volume inside it. It is just extracting it and attaching it to the VM. In a couple of seconds, here we go. We have our VM that is up and running. So what I expect now is I can connect to the console and just see if there is something. So we created a dedicated user that is the kiosk user. And again, we are starting Firefox in kiosk mode, and we expect to have our demo pulse point of sale available. So we can start making orders, we can start adding items to the cart, and then we can, of course, check out and print the receipt. And again, printing the receipt can also mean that you have a printer attached to that with the drivers and everything, because as we mentioned, the bootc images are potentially full of drivers and any other interface that you can read. And this closed the first use case. Now passing to Luca to see how we can actually manage these VMs.
Thank you, Ale. So I'll start again from basically the same container image, same example with the kiosk application. I will be showing a little bit different approach of just using GUI for building and managing bootc images. So flight control, I mentioned it before. You can find there the GitHub repo. There's also at least one developer in the audience from flight control, so you might want to connect with him. The important thing is that as most or every other product we've been showing, there's APIs exposed, so you can integrate it into your pipeline like we've seen with the previous demo. And then I'll be using KVM. Everybody knows KVM, so no need to do anything. This is a little bit the setup. So as you can see, I have two systems. I'm running flight control on Kind. By the way, there's an extension on Podman Desktop to manage Kind as well. I'm using Podman Desktop and I'm storing the images on Quay. So, so I'll start with the first build. We'll be using Podman Desktop. I'll fetch the container file and I'll decide what's the tag associated to this, and I'll start the build. So as you can see with Podman Desktop, there's a much more graphical representation of this. And in the end, we should have an image that's built, version 1. And we can now decide to push it. So all of this, most of you most likely are just using Podman CLI. This is now the extension dedicated to bootc images. And here I'm taking the container and building the QCow. So the same thing that Alex was showing before, but with a different tool, let's just say. I'm also using a config.toml to customize, in this case, the users that will be created inside the OS. And the QCow is almost created. And it's now available in a local output folder. So I'll just use virt install to create the virtual machines on KVM. And this is our CentOS 9 stream with the kiosk application. This is flight control. So flight control agent was included in this image, and I will now approve the device that was pending, that was trying to register to flight control instance, and I will create a fleet to manage this type of devices, so kiosk devices. I will decide the base image that it should reference, and I will set the monitoring of a specific systemd service. And now this is fully monitored, including the POS service associated to the container application. Now we'll build version 2. In this case, it's not a small feat, so we are actually upgrading from CentOS Stream 9 to CentOS Stream 10. But you will see that the upgrade from the device point of view is just another update. So I created already the image, I pushed it. I will change the template for the fleet and reference version 2. The rest of the information about the fleet is the same, and it will start updating automatically. So the agent will, as you can see in the log of the agent, will pull the update from Quay, and it will reboot into the new version with logically bound image, by the way. So we keep the same application even though we're switching the major version of the operating system. So we can now confirm it's CentOS Stream 10. And the same application is running, and the device is still fully monitored. So we see that the whole flow, including a major upgrade, managed in a very easy way.
And then before jumping into the Q&A, we just wanted to share with you a couple of links. Of course, the presentation will be available later. So the idea is to provide you the repo for both the demos. And then there is something that we started at Red Hat as, in our community of practice to create some, let's say, quick starts for Jenkins, for Tekton, for AWX, and for GitHub and GitLab, to just create some templates to automate the build and the conversion of the images. So if you want to have a look at that, we are continuously working on that. And now I think we can jump. If you have any question, just please let us know. Shoot it. And again, you can also see us around. So if you have something maybe later, curiosity or something like this. So if you have any question, please feel free to. Sorry, the last part? I didn't get the last part. Are you able to avoid the waiting till you work VM root at Tekton task level? Okay. So basically, I will just maybe repeat the question. So the idea is during the flow that we've seen during the demo, so we have also the build phase is very similar to what Conflux is doing. And the question is asking, can we wait for the VM, for the KubeVirt VM to be booted directly within Tekton task? The answer is, of course, yes. We can create some sort of timeout or just continuous check until the VM is up and running, because we can also maybe check when the VM is available for SSH or when a specific port is reachable on the host side. But again, this was just an example. So for the CI/CD pipeline, this was just one of the examples that you can do, because potentially you can expand this kind of use cases to exactly what is the use case that you want to implement. Again, when we talked about testing, also testing containers and testing the bootc containers, this can be part of a pipeline. Because if you have functional tests for your application before releasing it, or you have some specific test that needs to run on the machine before it's deployed or before the new version is rolled out, this is something that you can add at any stage of the pipeline. So absolutely, yes? Yes, please. Mm-hmm. Okay, so the idea, just let me get back to the question. So basically, the ask is if we can have some, if we are going through an approach of having a base image, let's say, where we are adding multiple layers on top of that. So the idea is basically what happens now, and it's completely true what you said, because, and this is one of the points that Luca addressed before. So if you're using a DNF update or something like this, of course you will end up with something that is not exactly the same as before. But the idea is you can do something like this. So you can create, let's say, a base image, a standard image that you are going to use with the base things that are there. So you can do the update only once, freeze the baseline, and don't update anything more than that, and use that base image as the new image for your derived images. So you have a, let's say, a standardized OS for your company, where you have all the agents, all the configuration, everything. You freeze that baseline, and then the developer, the DB admin, or anything is going to build their image based on that one. So it's not something that is going to that is addressed as at, let's say, at code level, but it's at the use case and best practice level. So basically, you can still do something like this and control the first build so that you don't drift from the baseline, and then using that as a frozen image, and then just build on top of that. That doesn't make sense. Cool. Cool. Now we are out of time. If you have any other question, we will be around. So thank you so much for your attention. Thank you, Luca, and have a great day. See you today.